The whistle blows. The stadium, a universe of 80,000 screaming people, goes so quiet you can hear a single cough from the upper deck. A player walks from the center circle to a small white dot, 120 yards of green grass that suddenly feels 1,000 miles long. He places the ball. He takes 3 steps back. He looks at the keeper, then at the net, then at the ball. He has done this 10,000 times in his life. He has scored from this exact spot since he was a child. His body knows what to do. His muscles have the memory. He runs up to the ball, and his leg feels like it's made of stone. The shot goes wide. Not even close. The crowd groans. The commentators say he choked. He crumbled under the pressure. His nerves got the best of him. And every single one of them is wrong. Because what happened on that field wasn't a mind going blank. It was a mind doing exactly what it was designed to do, and in the process, destroying the very skill it was trying to save. Let's start with what we think is happening. The common story is panic, fight or flight. The stakes get too high, your adrenal glands flood your system, your heart races, your palms sweat, and your rational brain just checks out. It's an evolutionary response. Your ancient lizard brain sees a threat, in this case, the threat of failure and humiliation, and it hijacks the system. Your body is preparing to survive, not to perform a complex motor skill. It's simple. It's intuitive. And for a long time, it's what most people, including scientists, believed. The mind gets overwhelmed and just shorts out. But here's where it gets complicated. Because when neuroscientists actually looked inside the brains of people choking under pressure, they found the exact opposite of a mind that had shorted out. They found a mind that was working way too hard. In 2010, Sian Baylock, a cognitive scientist then at the University of Chicago, published a book that pulled together years of her research on this exact moment. She studied expert golfers, professional musicians, students taking high-stakes exams. And she found a consistent, deeply counterintuitive pattern. The problem isn't that your brain turns off. The problem is that a part of your brain that should be quiet suddenly turns on, very loud. Think about how you learn any physical skill. Riding a bike, typing on a keyboard, kicking a soccer ball. At first, you rely on your prefrontal cortex. That's the conscious, analytical part of your brain, the CEO. It breaks the skill down into a clumsy, step-by-step instruction manual. Put left foot here. Shift weight. Swing right leg. Make contact with this part of the foot. It's slow. It's awkward. It's exhausting. But with practice, thousands of hours of it, the skill moves out of the prefrontal cortex. It gets handed off to the motor cortex and the cerebellum, the parts of the brain that handle automatic, unconscious processes. It becomes what we call muscle memory. It's no longer a set of instructions. It's a single, fluid, beautiful action. It becomes procedural memory, and the key to its success is that you are no longer thinking about it. This is the state athletes call being in the zone. It's fast, it's efficient, it's effortless. The conscious mind is just a passenger. The body just knows. And then comes the penalty kick. The world is watching. This one shot determines everything. And in that moment of intense pressure, your prefrontal cortex, the CEO, does what it thinks is helping. It wakes up and tries to take control again. It doesn't trust the automatic system to handle something this important. So it tries to supervise. It starts shouting instructions again, just like it did when you were a beginner. Make sure you plant your foot correctly. Don't lean back too far. Follow through. It tries to deconstruct a seamless, unconscious process back into its clumsy, conscious parts. Baylock called it paralysis by analysis. Your brain is literally fighting itself. The expert system that took 10,000 hours to build is being sabotaged by the novice system that thinks it's helping. You're not an expert anymore. In the one moment you need it most, your brain turns you back into a beginner. Your legs don't freeze because you're thinking too little. They freeze because you're thinking too much. And honestly, what comes next is even stranger. Because it's not just about thinking. It's about what you're thinking. Back in 1994, a Harvard psychologist named Daniel Wegner stumbled upon something he called ironic process theory. His experiments were simple. He'd tell people, whatever you do, do not think about a white bear. And of course, the only thing anyone could think about was a white bear. What Wegner discovered was that to obey a negative command like don't think of a white bear, your brain has to do two things at once. One part of your mind, the conscious part, actively tries to think of other things. A red car, a green tree, anything but the bear. But another part of your mind, an unconscious monitoring system, has to periodically check in to make sure you're not, in fact, thinking about the white bear. And what does it have to do to run that check? It has to bring up the image of a white bear. So the very act of trying not to think about something makes you think about it. Now, apply that to a penalty kick. The one thought in the player's head is, don't miss. Don't hit the post. Don't shoot it over the bar. Every single one of those thoughts is a negative command. To process don't hit the post, his brain's unconscious monitor has to call up a mental image of the ball hitting the post. He's trying to avoid an outcome by focusing on it. He is, quite literally, aiming at the thing he's trying to avoid. The instruction his muscles receive isn't score. It's a jumbled, contradictory mess of score, post, miss, and over the bar. The smooth, automatic program doesn't just get interrupted by the conscious brain. It gets fed a virus. So, that settles it, right? It's an overactive prefrontal cortex combined with the ironic command to not fail. Well, not quite. Because there's one more layer. When Baylock and her team put athletes in an fMRI scanner, they noticed something else happening under pressure. The amygdala, the brain's fear and emotion center, lights up. This we expect. But that heightened emotional state also interferes with working memory. That's the brain's temporary scratchpad, the part that holds information you need in the immediate moment. When working memory gets overloaded with worry and fear, there's less space for anything else. The conscious mind, already trying to control the uncontrollable, is now doing it with fewer cognitive resources. It's like trying to fly a fighter jet by reading the manual for the first time while the cockpit is on fire. This is a uniquely human problem. An animal doesn't have a concept of the future, of the consequences of failure, of the opinion of 80,000 people in a stadium. A cheetah doesn't lie awake at night replaying a missed opportunity to catch a gazelle. It doesn't worry about what the other cheetahs think of its performance. It exists in the present. Its prefrontal cortex is not developed enough to spin stories about what might happen if it fails. It just acts. We are the only species on the planet that can be paralyzed, not by the thing itself, but by our idea of the thing. The solution, then, is as paradoxical as the problem. The way to perform better is not to try harder. It's to find a way to get your conscious mind to shut up. This is why athletes have pre-shot rituals. A basketball player bouncing the ball 3 times. A golfer taking the same practice swing. These aren't superstitions. They are cognitive tricks designed to occupy the conscious mind with a simple, repetitive task, so it leaves the expert motor system alone. Some athletes sing a song in their head. Some focus on a single, external target, like one specific knot in the back of the net. Anything to distract the CEO, to keep the prefrontal cortex from getting involved and breaking what isn't broken. The goal isn't to clear the mind. It's to fill it with something useless. Every professional athlete who has ever performed at the highest level understands this, even if they don't know the neuroscience. They understand that mastery isn't about gaining more control. It's about learning how to give it up. So the next time you see a player walk that long walk from the center circle to the penalty spot, you're not just watching a test of skill. You're watching a battle being fought inside a human skull. It's a war between two separate minds, the fast, silent, beautiful expert who has practiced for a decade and the slow, loud, clumsy beginner who just showed up to help. The stadium goes quiet, and the player places the ball. He knows what to do. The question is whether he can stop himself from trying to do it. Because excellence isn't something you achieve. It's something you allow to happen once you finally learn to get out of your own way.